Alright, so previously we were working on this computational graph, and for some reason our graph was broken, and we just figured it out. And there were a lot of things which were wrong actually with our graph. So right now we're just able to debug all the problems with our graph, and seems like things are working because we are able to traverse all the nodes in our graph, right? After multi-head attention, we're able to successfully traverse all the nodes of graph, which is like super amazing. Whether they're leaf nodes or whether there are some operation nodes, we are able to traverse them. So it's a huge success. And right now we will be looking forward to implement this graph traversal with our attention layer norm as well. And let's see how it goes. Alright, so if I like run it one more time, you see that we have all the nodes over here, and this is the tensor ID associated with the node, and this is actually the operation. If it has some operation, this is coming from tensor slice, this is coming from tensor matimal, this is coming from operation slice. And you see, so we have a record for every single graph over there, which is a great thing. And right now, I still doubt that these are not all the tensors, to be honest. I still doubt that there are some tensors left, but who knows? I'll definitely have a way of testing this because I have a function called graph report, which I just read wrote the other day. So let me just pull that up. ATTN, where it is. So this is like graph validation, something like this. Yeah, so run graph validation, and this basically uh, creates a reports of all the nodes for me. How many nodes are there and how many of them were traversed. Wow. So this is something that's showing some information. If you see over here, so this is graph validation started over here, and it has parents. So 207 has 8 parents. So tensor ID 30 has 2 parents. So requires grad equals 1, but operations equals null. So there is something wrong. There's something wrong. So error requires grad, but grad equals null. So there is still an issue with our graph, right? And so null operations is 1 and grid is 1, right? 27 visited nodes. And now it's giving me some clue of this computational graph. So we have warning: tensor 0 requires grade 1, tensor 0 requires grade equals 1 but operations equals null. This is a warning, just leave it. This is the actual error: requires grade equals 1 but grade equals null. Well, I don't think if I should be worrying about tensor 0, because requires grade equals 1 but grade equals null. Yeah, there should be some grade, right? There should be some grade. But 95% this graph is just fine because we're having all the results coming from multi-head attention, and also we have this graph report, which is keeping track of every single node, right? And its parents, and whether it requires grad or not, and the operation that is associated with this, right? So far this looks good, but we'll definitely check this tensor grid 0, which is actually our starting tensor. Right now we are not too much bothered about it. And this being said, now I'm going to the next layer, which is right here, ln.c, and I'm gonna just comment this thing out because I don't need this main anymore. So what we are doing actually is we are testing layer by layer. And if I go to ln.c and let me see how it goes. So we have we don't need this, by the way. We have tensor operations right now. So initialize the parameters, and if we see here, mha init, params, we are actually initializing the parameters. So we should be initializing the parameters here in layer norm as well. So I think this should be ln init or layer norm, I guess. Layer norm init params. Or do we have such a method? Layer norm init, or let's just look for init. Well, it's already initializing the parameters. Oh, so we need to set the grad equals true. So we have ln beta grad equals true, requires grad equals true, and this has gamma, and this also requires grad equals true. And now we have d derivative of beta, so d beta true, and d gamma requires grad equals true. So we have actually initialized the parameters, and let's see what happens over here. So we are here, and so where is layer norm for? So basically what happens is it's creating the layer norm, and it's like defining the features, defining the dimensions, right? And this is the shape, weights. Yeah, so this is pretty much it. We've initialized the parameters, and now we are going to the layer norm forward method, which is right here, and takes arena and takes layer norm tensor x, which is the output of multi-head attention, by the way. And we will be running some computations like here, and everything is abstracted. By abstracted we mean that now we have tensor operations rather than just floating point numbers. And this is tensor expand columns. I think I should check this function first of all, because I don't want to make the same mistake. So tensor expand columns, uh, tensor expand columns, and requires grad. So it has only one parent. And what is out columns? Okay, so listen, out columns, man. And if we go to tensor.h and see, we have out grid parameter not for tensor abstract. So we have column, we have not out column, right? So we don't have this one, so let's just go to tensor expand columns again, and this time we're gonna yeah, this is columns and out columns. Fine. So let me take a look at one more time. So we have parents, we have created a space at the arena, and we have m as a first parent, and then we have ops backward, expand columns backward, and then we have assigned operations to op, and then we have tensor create new. Fine, looks good, right? This is the actual logic, and r times columns, out columns plus c equals v, right? And this is expanding our columns, right? So c equals 0, c lives in out columns, c plus plus, r times out columns plus c equals v, right? Okay, perfect. Okay, this is good. So if I come over here now, ln.c. So first of all, we're just initializing the arena. We have this thing. We have a new tensor, which is this. And first of all, let's just x requires start this grad equals true, and we have integer features. And have we initialized? Okay, the parameters. Let's just check. Oh, layer none forward. Is it initializing the parameters? I think it should initialize the parameters. Okay, so layer non create. This initializes the parameters. Uh, ah, okay, yeah. Here it's initializing the parameters, I guess. So I don't have dedicated function for this class. Uh, so in case if I can check from here, layer norm dot edge. So we have init parameters for a function, right? We have this, and if I go here, see, init parameters. We have this init parameters, right? And okay, so let's just initiate them, uh, initialize them, and just print something over here. Okay, and then we have this tensor x, and where's MHA, by the way? So layer norm forward. Okay, so layer norm forward. Do we have MHA over here? We don't. We don't. Right. So we're checking layer by layer, and like each layer is, separately testing its own parameters and its own graph. We should not be doing this though, right? What we should be doing instead is we should check, all the previous layers in the current layer, right? But we're checking all the parameters of the current layer itself, but not the previous ones. Okay, we'll look into this later. So layer norm forward, and this is our out. And let's see if we are able to traverse the graph of this out. And traverse graph out, and what does it take? Okay, so tensor yeah, visited and root tensor. So we have something called vislist, bool visited equals vislist a and max nodes, I guess. This is how it works. So can we just create tmux session, because it's getting really messy over here. So ln all right, so we have this thing, and if we check vim tensor.c vislist, okay, so it returns a pointer, right? And it takes max nodes or nothing. It just doesn't take nothing, not even arena. Perfect. And we have out here and visited here. Okay, like so. And there's something wrong with my OBS.